Okay, let's do some stuff with MC. So I'd like to make a kind of a textured pad that's based on a single sample being played back multiple times on top of itself with different pitches, different panning positions and that kind of stuff. So we'll start with a cello sample. I've got one in here which is kind of snipped off the end of some piece of bark, I think. That sounds quite nice, so we'll just grab that, and if you hold down option, I think it is, then you get this menu and you can just create a buffer object like that, and then you just double click in here, and I normally just remove that stuff and put in my own name for the buffer. This you can just put up here somewhere. We're going to reference that later. So we'll reference this using mc.groove tilde, which is the multi-channel version of the normal groove object, which you can use for playing back samples. Well, I'd like to come up with some chords or something I can use. I don't really know what I want yet, but I know that I would like to be able to feed in a set of MIDI notes into the groove object, and every time a note is played, that will play back the cello sample at that pitch, and then I can use all kinds of other processing to generate multiple notes on top of each other. So to start with, we'll take a K slider, which I can then use to generate MIDI notes, and on this, I think this outlet will just, out of here, will give me a whatever MIDI note number it is. To do that, I just, when with this selected, you can hold down Shift and hit I, or you can hit F to create a floating point, or whatever. These are just shortcuts. So this is my MIDI note number, and I want this to go into the groove object. But groove, let's take it as mc.groove for now. Call it cello to point to that buffer. We'll give it channels in a minute. This doesn't accept frequencies. This accepts playback speed. So when you send it a signal of a value 1, then it will play back at normal speed. When you send it a signal of playback 2, it will double it. 0.5 is half speed, 0.25 is quarter speed. So it's, these are octaves, but they don't, as you can see, they don't scale linearly. They scale exponentially. So we need to convert this into this. Luckily, there is a way of doing that. If you open up the Groove help file, you see this. This allows you to change MIDI note numbers into signal values for the groove. So you could just take all of this, copy it, and then paste it out into here. And going through this in turn. So ignore this thing for a minute. What this will do is it'll send the integer, which is this 71 value, whatever you've clicked on here, into this expression object, which then converts it into a transposition ratio, which you can then put into a signal object and then stick into your MC groove. That's absolutely fine. That will work brilliantly on a single channel groove object. Doesn't really work on multi-channel, and that's because we need multi-channel signal to go into the MC groove object. So just get rid of this for a minute. We don't actually need all this helper text. We'll just get rid of that as well. So I'm going to add another B on here, and what this T object does is in going right to left, it sends out of these different outputs whatever it gets in here. So this is literally out of this right output, it's going to send a bang whenever I click on a key. The middle output, it will send the value 55, which is coming down here, and out the left output it should send the number 0, which we'll use in a minute. So let's convert this into a multi-channel version. Let's make this a bit wider so we can see what we're doing slightly easier. So I would like, let's say, one of the great things about MC is you can have pretty much unlimited channels available to you. So, you know, unlike much, you can go for polyphony of 2000 if your computer can handle it and get really dense textures. My computer probably won't handle it because it's a bit old. So what I'd like to do is let's use an mc.sig object to generate these signals, which is the multi-channel version of this, and let's give it chans of, well, let's say 30. I'm just picking a number at random there. Now I can send this straight into here, but unfortunately that will turn all channels to this note, and I actually want to go through them in turn. So when I hit a note, I want the first channel of the mc.sig tilde object to be that note, and then hit another note and it'll be the second channel, third, fourth, fifth, sixth, seventh, all the way up to 30, and then loop round. Well, there's a great object for that, isn't there, which is counter object. So it's going to count from 1 to 30. And then if I do this, you can see that's just counting all the way through, and then you can see it looping around as I send lots of events to it. So the MC objects are, the channel numbers are 1 base, not 0 base. So they start counting at 1. And to cycle through, what you can do is use this MC target object. And what that does is you send a channel number to the right inlet. So this will be my 1, 2, 3, 4, 5 up to 30. And then whatever message you want to send to your target object, you send to this. So you can see a message to target. So I'm going to send these ratios through to this, and then come down here. And what that will do is, it's actually quite a simple object. Let's click on one of these, and if you can see, through here has come my channel number 22. Through here has come my frequency, or I said my pitch ratio of 42.71. That's a bit high, by the way. We'll have to deal with that later. And it's set value 22, 42.71. Now you can do this with a pack object, and you'd have to swap the inlets, but it's very easy to just use this MC target. That goes straight into mc.sig. By the time you've collected all these, you can see them coming out. So this will now be sending a multi-channel object. You can see it there, it's coming through 42.71, coming through at 20. So if I do this and send a load of objects to it, now you can see that all of these pitches are coming through 1 per channel. And so when this receives a start command, it will play back at that particular pitch. Now as you can see, 42 is ridiculously high. The cello is, I don't know exactly what note it is, kind of doesn't really matter, but it's probably 3 or 4 octaves below that. You can add a minus into here, which is probably the quickest way of doing it. What I'm actually going to do is just remove a few octaves from here. So let's take 60 away from the pitch value, and that will hopefully clean it up a little bit in terms of pitch ratio. So if I come through like this, and then on here, so that's much better actually. You can see they're all down in kind of somewhere around at pitch or below or above, which is slightly more rational than 42 times the frequency, which would be ear splitting. So this isn't playing back yet, but this is now, it understands that when it receives a play command through to that particular channel, it will play that particular channel at pitch. And the way to do that is with another MC target object. So we'll just copy this over here and put the channel counter in again. So what do we need to send to an mc.groove object to get it to play? Well, I'd like to play from the start. And to play from the start, you just send a 0. So we're just going to send a simple 0 through. So then when I click on one of these, it will say set value channel 11, number 0. That will now play back. So what we should get now, coming through here, is a multi-channel signal output. 30 channels, so quite large. Of these different things, every time I click one of these, it'll play it back at that pitch. We can't really deal with 30 channels in. We need to mix it down to stereo in order to hear it properly. So beneath this, I'm just going to add an MC mixdown object, which is a straightforward way of doing that. Because I'm going to play lots of notes, I want to auto gain this, and what that does is it compensates the volume of all the channels, so that we don't end up with kind of 30 channels playing at once and blowing up the audio. It'll scale it down by 30, so that if you do play them all at once, it'll be a unity gain, which is pretty clever and a good way of dealing with it. So now I have a stereo object. I can come into a MC live gain, and we should see something on this. We can't hear it yet, but we should see it. There you go. So you can see it coming through. So I want to hear this now. So in order to do that, we need to send it to a DAC object, or an MC DAC object. And I'm going to do this in a slightly funny way, because I'm routing the audio out through so I can record it. So I'm going to send my thing to an unpack object, and that will give me a separate single channel MSP audio streams, which I can then send to my DAC output channels 1 and 2. And I'm also going to send it to 3 and 4, because that's where I'm recording it. So I'll send that one to 1 and 3, I'll send that to 2 and 4, and there we go. That is that, which is simple. So what can we do with this? Well, one thing you can hear is that every time I play a note, it's cycling left and right. And that's because it's looping up through the channels, and what mixdown does is it basically alternates through the channels. So all the odd numbered channels, 1, 3, 5, 7 and 9, are mixed down to channel 1, and all the even numbered channels are mixed down to channel 2. So that alternates them as you go through. It's quite nice. You get a sort of hard panning effect. But what I'd like to do instead is mix them at a random point in the stereo field. So to do that, we need another MC sig tilde object, which is going to give us our stereo information. And we're going to randomize this. So in order to do that, we need to create a set of random pan values. And I'm going to do this between 0 and 1, just because I think that's slightly easier to get your head around than the complex circular panning stuff which MC Mixdown uses by default. So we're going to switch it into 0 to 1 pan control mode, which is pan control mode 1. So if I go into here, now you can see linear panning is pan control mode 1, and that goes between 0 and 1, and it will pan channels, pan between left and right, where left is 0 and right is 1. So I think that's more intuitive than many of the other ways of doing it. So we need to create a random number between 0 and 1. So I'm just going to do that with a simple random up to 100. And then I'm just going to divide that by 101. So you get a number between 0 and 1. 101 because random 100 only goes up to 99. Okay. Now, notice that we need to connect this to somewhere, and it's going to go weird if I do it there. So I need to add another B in there, and this really strictly enforces the ordering of the information. So I always want my MC target to receive its channel number first, so that will always be my rightmost outlet from here. This third one along here will be the other bang, so that will come in next, and that will go into my my MC target object, and hopefully this will create exactly as this has created some random pitch signals. This will create some random pan signals, and as I do this, we can see them all coming through here, randomly panned somewhere between left and right. So that's quite pretty. So let's just put this horizontally so we have a bit more space, because otherwise we're going to run out of space. So now we've got this. I mean, obviously I'm not going to click a keyboard, so let's create some interesting pitch information. So what I'd like to do is maybe a set of chords and cycle through the chords, and maybe have a kind of a set of notes, and you move through a sequence of notes, and then kind of energetically play each note like in an arpeggio. So the arpeggio is quite rapid, but the chord shape shifts over time. So I'm just going to capture a bunch of this in a message object, and I mean let's do a list stream, and let's take 16. So what this will do is it will take 16 notes, and it'll grab the last 16 of them, and it'll put them into here, into this message object once I'm finished. So we'll do, let's say, something quite simple like, and then one more. I don't know. There you go. So that's I'll just get rid of this now. So this is my MIDI information over here. And this is one of the fun things about Macs, is that you are forced sometimes to use this kind of way of doing things with MIDI note numbers instead of more intuitive musical information, but it does allow you to do things in a bit more of a fun way. So what we'll do is these are the note values that we want to send. I'll just get rid of that for now. But let's say I want to arpeggiate the last 3 notes. Well, I just want to cycle through this. So I'm going to use that same list stream object. I'm going to take let's take the last 4 notes actually. And what I'm going to do is I'm going to say, I'm going to counter between, well, it's 16 notes in there, so that'll be from 0 to 15. And then I'm going to list lookup. And what the list lookup object does is, depending on the list information you send to the right inlet, and the index number you send to the left inlet, it will then look up from this list whichever index you're sending in. So if I do an output like this, and then bang into my counter object, it will count through, and it will move its way through the sequence like that. So you can see it's kind of working its way through that sequence, which I think is fine. And you can see the index number here if you want, as that moves through. So this is like a little lookup table of note values now of that sequence that I just played on the keyboard. So that's fine. That's going to give me that. Maybe we'll have a metro object in there that kind of updates every second or so. This @active1 attribute means that you can avoid using that annoying toggle object, and let's just keep going automatically, giving me our musical notes. So what I'll do is I'll feed this into here, and then if I come out into another message object, you can see this is just it's kind of the last 4 notes that are being played, which is my kind of notes that I want to pick from for my arpeggiator. So I can now send those through here in exactly the same way. So with a much faster metro object, let's say metro 100, I can then say, well, let's do counter 3 on this one. That'll be like an up arpeggiator, and then a list lookup again down here, and then we just come down here like this. And what this will do is, with these very, very fast kind of counter index numbers coming through here, it should now just loop through this changing thing and give me a bunch of MIDI note numbers like that, which I now can just send here. So obviously all of this can be shifted. You might want to go a bit faster than. Well, you could, rather than having it like a up arpeggiator, go and do it random. I think this is. quite nice. And obviously you can do whatever you want with this now. So you can have it so it randomly goes up the octave, if you want. Just turn that down a bit. Why don't we have it so it randomly goes up the octave? So the best way to do that, I think, is whatever information is coming in here, just add 12 to it every now and again. So I will stick another trigger object in there, like that. So this is these are my notes coming through here. Let's move this down a bit. We don't need that to be as spacious anymore. And I'm going to do a random, let's say a 1 in 4 chance, right? So that will give me a number from 0 to 3 out here. And whenever it's a 0, we will add, whenever it's a 0, we will add 12. So we'll do select zeros, and then what we'll do is we will just put an add object in there. There's better ways of doing this, but I'm dumb, so I'm going to do it a stupid way. So I'm going to say add 12 to it whenever that first one hits, so I can go into there. And whenever it's not a 0, which will be this right outlet, it adds 0, so actually it's keeping the pitch the same. So that's quite pretty now, that's like a kind of fun. Now these are all quite harsh attacks on these, so I think we can do something to soften the attack of each of the notes, which you would do before you mix down. So what's coming in here is just a full playback of the sample. So we need to add what we'll do is we'll add an envelope to this, and to do that you would just do an MC asterisk tilde object, which is like a standard signal multiplication thing, but it will work on each channel. So we're going to do this again with another thing, but rather than MC sig, let's do an MC curve, right? And then so this will come again from our counter object, which I'm going to keep on the right hand side just for so it's really obvious what's going on over here. And then we need a function object, and I think you do mode 1 to get curves on it. And we're going to take that bang, as long as it happens after the counter object. We can reuse the same bang that we're using for the random panning thing. And then just as you would feed a curve tilde object with the second outlet of a function object, you just feed the MC target and that will give you your data. So if we do that, that's giving us the same curve actually, and that will just send it to each of these objects. That will give us the short thing, multiplying by that, nice and soft. But I did say it was a bit too, it was a slightly harsh, so we're just going to soften up like that. So you can mess around with this and do whatever you want with it, really. So I quite like this. It's a good way of doing things. Add a 24 to that, so it's about 2 octaves. You could even randomise the volumes of these if you wanted to. For a bit less uniform sound. And I would just do that with another one of these. I'll just do another one of these, actually. And that will generate another set of signals between the same as well. Multiply your curve object like that. That's coming in there, and that can come in there. So there now, different volumes. They're coming through quite quickly here, I think. So you could actually add a few more channels to this if you wanted to let this. You see. Change all these to 60. And as long as you're doing things in this stage here before you get to mixdown, you can process individual channels differently however you want. I mean, you can filter them differently. The key to all of this is have a counter object which is running through your channel numbers into the right inlet of an MC target object, and then a multi-channel version of whatever you want to do. So filtering randomly would be as great. For each node randomly would be as simple as saying, well, what your random value is, scale that to whatever frequency range you want, go into your MC target, and then just have an MC dot low res or an MC dot SVF tilde object, whatever you want really, and you can process each one of these channels of the MC signal however you want. This is approximately 2 seconds long, this audio file. So, I'm going to start it a bit later. Get silence now. And I'm going to take this. I'm going to multiply by -1. Now all of these are in reverse. I'm just playing back in reverse. It's quite nice. we've got some bass notes in here you can hear. To grab those out, you can just take this and that will always give you the first one. It will always be the lowest note in there. So why don't we take that? That's it. You can do other stuff with these bass notes if you want. Maybe it's a cycle object or something. But it adds some, take some octaves off it. Obviously, I don't know what the original cello sample is tuned to, but it is not concert pitch, so these are very strange notes. It's probably a C. So what's C? That's 3 semitones. No, C would be at concert pitch. It's clearly not a C. I don't know what it was. I assume that it's a traditional instruments Bach string quartet or something. It won't be even tuned at 440 hertz. Well, there you go, you have a fun bass line that's off key. Quite nice. Alright, it's nice enough. Hope that's useful.